So remember that one of the important roles of concepts in cognition is to help encode, organize, and retrieve information. They are essentially the highways that we serve to get at specific kinds of information. So, an important aspect of a theory of concepts is going to be its interconceptual structure. That is, how are concepts organized to facilitate not just storage of concept relevant information, but also information about concepts that are related or important to the original concept. So the similarity-based approach has attributes as its primary conceptual structure, and as a result, any interconceptual structure has got to be based on a hierarchy of shared attributes. The theory-based approach has more structure, more information, and so it can use a network that's formed by causal and explanatory links. And then it can relate concepts by sharing properties picked out as relevant using those causal and explanatory links. You might think, well, that's very abstract. I'm not sure how that's supposed to work. So we can imagine how the similarity-based approach would have to work. So let's say we have the concept of animals. Now it should be related to a subset, the concept of house pets. The only way they could be related is if house pets have a set of attributes that are a subset of the attributes that are diagnostic of animals. Similarly, dogs, cats, fish, and birds, instances of house pets, would have to have that same relationship to house pets. That is, they would have to have attributes that were part of a subset of the superset of attributes that defined house pets. So ultimately, right, animals would have to contain all of those attributes, or at least a significantly large portion of them, so that they could be related to house pets and then to instances of house pets. The theory-based approach seems a little more plausible. So suppose we have the concept of a cake. It could be related to a whole bunch of different concepts having to do with the production of a cake. That is, the making of cakes. So the concept of sifting flour, of measuring, of adding ingredients, of cracking eggs, of mixing, of baking, of testing, of frosting. All of these things are steps in the production of a cake, and hence could be linked to the cake through their inferential principles, through the causal explanatory rules. What about conceptual development? How do concepts change during the course of maturation or just over time? Well, again, the similarity-based approach only has really features and weights on those features. And so concepts would have to change through feature accretion, adding or getting rid of particular features and increasing or decreasing weights on features. The theory-based approach has a richer structure, a richer set of information. And so conceptual development can occur through the changing organization of the concept itself and explanations of concepts as a result of world knowledge. So as a child develops more knowledge about what it is to be a mammal versus what it is to be a bird, they can start to become clearer on the distinction between, say, bats, penguins. So ultimately, we see that theory-based approaches modify the similarity view in four basic ways. Theory-based approaches hold that similarity must be based on attributes, just like the similarity view, on relationships, and on higher order properties like function, causality, context, and modality. Properties are not thought of as independent and additive as they are in the similarity-based approaches, but they are linked to a variety of inter-property relationships like function, causality, and context. properties exist at multiple levels of abstraction in the theory view, whereas properties in the similarity view are all at roughly the same level of abstraction. And finally, concepts are more than just lists of attributes. They're structured relationships that encode attributes, relations, principles. They include rules as well as features. So in effect, the theory-based views of concepts attempt to reintroduce rules into conceptual structure. They certainly don't go back to the classical view of concepts where they're trying to articulate the essence of a concept through articulating the individually necessary and jointly sufficient conditions. But they do seem to introduce things that would naturally be encoded in terms of rules. That is, they seem to suggest that relationships like explanation and causality and context help to structure concepts in ways that the similarity view doesn't. Now, it's important to sort of notice that the classical view, the similarity views, and the theory-based views are all views that suppose that there's one monolithic process or system that learns concepts, stores concepts, and categorizes things in the world. And this view actually has come under fire, I'd say, within the last decade to 15 years or so. And I'll talk about one version of the most recent incarnation of theories of concepts, namely the multiple systems view. And the one version I'll look at is Covis. And we'll look at that in part because Gregory Ashby is up at UC Santa Barbara, and in part because I think it's a pretty good version of this multiple systems view. So theorists like Ashby have come to reject the notion that we should search for a single, all-encompassing view of concepts and of categorization. And instead, what they've done is they're suggesting that there are two, or maybe even more, competing systems for concepts and categorizations in humans. And they propose that there's a rule-based system and a similarity-based system. And these systems operate in parallel and compete in categorization tasks. And in the next module, we'll talk about Covis itself and the multiple systems view.